Hi there. So today we're going to learn how to complete a square, and by completing a square we can solve more difficult quadratic equations. Now before we learn how to complete a square, we need to be very good at doing problems like the two we see here. So solving this problem, x squared is equal to 16. Well, x is going to be equal to, if we take the square root of both sides, that way this and this will cancel out. We'll be left with x is equal to the square root of 16. X is therefore equal to 4. And hopefully you should be able to see that 4 squared will give us 16. However, if we were to do minus 4 squared, the product will still be 16, because the product of two negative numbers multiplied by each other will give a positive number. So we can rewrite this as x is equal to plus minus root 16. X is therefore equal to either positive 4 or x is equal to negative 4. So either of these solutions will work and will satisfy this equation here. Likewise, in this example, if we take the square root of both sides, we'll be left with x is equal to plus minus the square root of 25. X is therefore equal to either positive 5 or x is equal to negative 5. And again, both of these solutions will satisfy this equation. Now, moving on to completing a square, and we're going to use some shapes and a bit of geometry to solve the first problem. So this is a quadratic equation, and we won't be able to solve this using the traditional method. And the traditional method is where we think of two numbers, so two numbers that add to give 6, and the same two numbers that multiply to give 7. Now the factors of 7 are only 1 and 7, and if I was to put 1 and 7 up here, this statement, so 1 plus 7, is not going to be equal to 6. So we can't actually solve this using this traditional method. So completing a square will come handy in these examples. Now, let's try and solve this by thinking about squares and rectangles. So this square here, the area of this square is going to be x squared. So that's the third term in our quadratic equation. So the area of this is going to be x squared. So that means the length of sides is going to be x and x, because to work out the area of a rectangle or a square, we would do the base multiplied by the height. Now, likewise here, if the area of this rectangle is 6x, this height is equivalent to this height here. So this height is going to be x, and the base is going to be 6. 6 times x will give us 6x. And for this last rectangle, it doesn't really matter whether you deal with this or not, but we can just pick two random numbers. So I'm going to pick 2 multiplied by 3.5 to give us 7. So we have x squared plus 6x plus 7, and we've rewritten our equation using squares and rectangles. Now what I'm going to do is split this middle rectangle in half. So I would get something like this, and then I'm going to merge these two rectangles onto the square that I started with. Now, one thing to be clear of, once we split this rectangle into two halves, the length of sides are going to change. Now, the height of the rectangle is still going to be x, but the width is now going to be 3. Likewise, with this rectangle, the height is going to be x, but the width is going to be 3. And 3 times x is going to give us 3x. 3 times x will also give us 3x here. And if we were to add these two together, we would get an area of 6x, as we have up here. So I'm just going to write these over here, just so we remember the dimensions. So 3 by x and 3 by x. And if I just rub out what I've got here, so if we merge these two rectangles onto the square, what we'll end up with is something like this. And I'm just going to rub this out to make life a little bit easier. So now that we've merged this, what we can do is actually write the dimensions of this shape that we've created. So the length of the square is still, or the width rather, is still going to be x, and the height is still going to be x, and then we're adding this additional bit. Well, this length of side, so from here to here, is going to be 3, as shown in this diagram here on the left hand side. And with this rectangle, this distance here, so from here to here, is also going to be 3. So the overall height of our shape is going to be x plus 3, and the overall width of our shape is going to be x plus 3. Now, if I was to create a perfect square here, what would happen if we were to try and work out the area of the whole shape, including this bit? So seeing as we've created a square, the area is going to be the base multiplied by the height. So the base is going to be x plus 3 multiplied by this height here, which is also going to be x plus 3. So rather than writing x plus 3 times x plus 3, I can just simply write x plus 3 squared, and that will give me the area of this whole square. However, in reality, I want the area of the shaded region. So I want the area of everything that's shaded in grey. So I must subtract the area of this square that I have created here, and I've now shaded in black. So the area of the square, well, the width of this square is going to be 3, and the height of this square is going to be 3 as well. So the area of this square is going to be 9. And if I just use a different color pen, we can see that the area of this square is equal to 9. So what we need to do is subtract 9 away from the whole shape to get the area of the grey region. So our answer for now is going to be x plus 3 squared minus 9, and then we have this 7 here, and we will add 7, and that will be equal to 0. So we've now completed the square. This is what your answer would look like if you were to complete the square. And what we'll have, if we were to simplify this, is x squared plus 3, x plus 3 in brackets squared, and then minus 9 plus 7 is going to be minus 2, is equal to 0. And then once we have our answer in this format, we can actually solve what we have here. And I will do this on the next slide. So looking back at our problem, so the answer that we got was x plus 3 in brackets squared minus 2 is equal to 0. Now to get this, we can now think about a general formula. So what we did is, initially we said every quadratic equation is in the form ax squared plus bx plus c is equal to 0. So what we've actually done is, we have done x plus half of our b term. So our b term is 6, and half of 6 is 3. So it's going to be b over 2 squared minus b over 2 squared. So minus b over 2 squared. So again, b is 6, so 6 over 2 is going to be 3, and 3 squared is going to be 9, plus c, and our c term is 7. So what that would have left us with is x plus 6 over 2 is 3 squared minus 6 over 2, 3 squared, 9, plus c, and our c term is 7, which is equal to 0. Therefore, we have x plus 3 squared minus 2 is equal to 0. So this is the general formula for completing the square. And if it's quite difficult to remember this, you could think about it using the shapes as we did earlier. Now to solve this, so we want to get rid of this -2, so we have to add 2 to both sides. So -2 and 2 will cancel out. We'll be left with x plus 3 squared is equal to 2. Then we need to take the square root of both sides to get rid of this index over here. So what we'll be left with is x plus 3 is equal to plus minus root 2. And then we want to get rid of this 3. So we would have to subtract 3 from both sides. So x is equal to minus 3 plus root 2, or minus 3 minus root 2. And the reason why we do minus 3 minus root 2, because we have to do positive root 2 and then negative root 2. And I'm just going to cross these out to see that they cancel out. So these are our two solutions for the value of x when we complete the square. Now, let's try another example. So write x squared plus 8x plus 5 in the form of x plus 8 in brackets squared plus b. So when they give you a question like this and they tell you to write it in this format, it means you need to complete the square. And if we use the pen, so this should tell you that we need to complete the square. Now, if I use the shapes again, so I can rewrite x squared as a square, or I can draw x squared as a square with base x and height x, plus a rectangle with a height of x and width of 8, plus a rectangle. Again, these are not drawn to scale, with an area of 5. So we can just use, say, 2.5 and 2 for this. But this rectangle here is not very important. Now, again, we need to split this middle rectangle in half and merge it onto the square. So if I was to split this in half, I will be left with x by 4 and x by 4. 4 times x is 4x, 4 times x is 4x. So 4x plus 4x still would make 8x. And again, apologies that these are not drawn to scale. So let's merge these two onto this square here. So we have x squared, and then we can take one of these rectangles and put it on top of the square. This width is going to be x. This height here is going to be 4. This width, the distance from here to here, is going to be x. The distance from here to here is also going to be x. Now, if we take this rectangle, we can put it by the square vertically. And again, the base is going to be 4 and the height is going to be x. So to work out the area of the whole square, if I was to create or complete the square, to work out the area of the whole square, I would have to do the height multiplied by the base, and the height is going to be x plus 4. So that's going to give us x plus 4 multiplied by the base, which is also x plus 4, so it's going to be x plus 4 squared. However, I only want the area of the shaded region, so I must subtract this bit away. And if I was to subtract this bit away, I need to find out what the dimensions of this pink square is going to be. Well, the dimensions of the pink square is going to be base of 4 and a height of 4, so the area of the square is actually going to be 16. So I need to subtract 16 away, and then don't forget about the 5 that we have here. So it's going to be minus 16 plus 5 is equal to 0. So what we're going to end up with, if we simplify this, is x plus 4 squared minus 11 is equal to 0. And we've given our answer in the form that the question has asked for. Now, if you were to ask to solve this, you would then do plus 11 on both sides. What we're going to be left with is these two 11s cancel out, is x plus 4 squared is equal to 11. We need to take the square root of both sides to get rid of the index. What we'll be left with is x plus 4 is equal to plus minus 11. And then to get rid of this 4, we would have to subtract 4 from both sides. What we'll be left with is x is equal to, and in fact, I better write this over here on the side. What we'll be left with is x is equal to the square root of 11 minus 4, or x is equal to negative root 11 minus 4. And that would be your solutions for x. And this is your answer for what the question is actually asking for. Thank you very much for listening, and I hope you found this useful.